Hello and welcome to this video, guys. Today we're going to look into the strategy pattern, which is a design pattern that is commonly used in Angular application. In the context of Angular, the strategy pattern is often used to define a family of algorithms and encapsulate each one of them as a separate class. And this allows the algorithms to be selected at runtime based on the application's needs. So let's look into an actual use case where we could implement it. So let's go ahead and say we have an interface, so export interface sorting strategy. And here we have just the interface on how it would look like. Let's not add any types for now. We can essentially create a new file, so let's call it sorting strategy.ts. So obviously this needs to be placed in a better folder structure. Now for demonstration purposes we will not do that. So we can remove it from the app component. Now let's create some clauses that will implement this actual interface that we have. So we can write export clause, ascending sorting strategy, and it implements the strategy that we had here. And let's see here, saving this, you see that we now have one function which essentially just sorts the items that we have. But let's go ahead and sort it in the ascending order. So A, B, and here you would just do A minus B. This would sort it within the ascending order. You could also do the same thing, generating a new clause called descending sorting order strategy, and it implements this interface as well. And here instead it will be B minus A. So now we have implemented the strategy here. So the strategy pattern that we have, and to utilize it, we can do a couple of things. So within our component, let's say we are injecting the private sorting strategy, which is of type sorting strategy. Import it. We can also say, yeah, it's all right. So let's give it a type on the constructor. So we can say when we first call this function, we're going to set the sorting strategy to be in an ascending way. So we're going to say that this is our default thing that we will do. All right, so the question is, what do we more need to do than this? We have set the default sorting strategy. Now we can create a function here. So set sorting strategy, and here we would have the sorting strategy here as an improp, and here we are going to say we're just going to replace the sorting strategy that we have. And we're going to create a function here called sort, and it's going to be the same typing that we had before. And here we have the any tag, and here we're going to say this return this dot sorting strategy sort, and we're going to pass in the items that we have. So given we have some items within the component, so for instance, if we would just generate a list of items, so we would go ahead and say 1, 2, 3, 4, 5, 6. Now they are sorted, in fact, so let's go ahead and just make them a bit random. So now that we have sorted items, or not sorted items really, we can utilize this by calling the new on the ascending sorting strategy, and we can also say that this this dot sorting strategy sort, and we can pass in the item. So now that it is in fact being sorted in an ascending order, this is what we can do. So let's add this here. Once we have this here, we will sort the items, and as mentioned, since we're setting the ascending sorting order to be a default, in this case it will sort it in an ascending order. So if we want to change it, we can either have a function which takes this as an in parameter, or we could essentially just say that this sorting strategy equals to new descending strategy here, and then if we would sort this, we would sort it in the other way around. So sort this item. So in this way, we're having one clause which we can that implements. We have two functions that implements this sorting strategy, so that we can easily use it in this way, encapsulating the functions and stuff that we need. So this is one way of actually utilizing the strategy sorting strategy way. So let's say we would have functions called sort in desk. And as you can see, instead of having all of this boilerplate code, we could have it instead in this way. So we could call the function, and here we could do the same thing. So sort in ascending. So we could just snatch this real quick hit from here, and then we could just do a couple of things. Obviously, we need to have something defined on the constructor, otherwise this will complain. We could also say that it's going to be new ascending as a default here, so that then we do not really need to have it here. So let's make sure we wrap the lines so that we can preview everything within the screen that we have. And as we can see here now, we have a pretty clean pattern on how to work with the sorting and descending orders of the actual items that we have. So in order for us to really test this out and preview it, let's save the sorting strategy. Let's also close it, save the app component, and open a window next to this one. So once this is done, let's go to the app component file, and we're going to add a couple of things. So we're just going to print the items that we had in JSON format. So doing this, we should shortly see that it's actually being sorted. Maybe not on init because we are not calling it to be sorted really. So here we could say we could actually have two buttons. So let's go ahead and two buttons. So button. So when you click this button, sort in ascending, and we could do the same thing for descending. All right. So all right. So now that we have the two buttons, when we click it, we should see that it actually sorts the array. So this is the strategy pattern. In my opinion, I do not really like this pattern because I think that there's a lot of boilerplate code that you need to have in order to implement this. In my opinion, this could be generalized in another way. So let's look at that. So first and foremost, the most basic cases is where we have numbers, and as you know, it will be objects in the future, most likely not have any numbers at all. Alright, so let's put the screen side by side. Now that we have the screen side by side, we have the sorting strategy to the right, and let's get rid of the any tags that we have. We're going to start to utilize the template T, the generic type T in this case, so we're going to continue working with this, and here we need to obviously do the same for the other parts. We'll jump into it real quick, why we want to work with it in this way, and why what the benefits are working with this as well. Alright, so now that we have it implemented, as you can see here, we have some type errors because we will never know if A and B will be a number, string, and so on. So we're going to make one thing to solve this. So alright, to continue, we're going to create a generalized function for all objects that we have. So in order for us to do that, there's a couple of things we need to change, alright? So within our sort, we want to have we want to have a callback. So the callback is going to be, it's just going to take the item, which is of type T, and it's going to return some value that we have in our object. So this is how you type it. It says item, which is of type T. So if I would now have a product in this case, or a person really in this case, the T would then reflect this type. So it would, the generic type would then become ID number, name, string. So it would, under the hood, create this generic type, and it would still receive it from the object that we're passing in. Alright, so what is then T key of T? If you're a bit confused about this, I was in the beginning as well, but T key of T would essentially mean in the object T, we're going to select the key, a key of T. Alright, so this means a key of T in this case might be name, it might be ID, and obviously as strings. So this is one way of generalizing the typing of how to actually write this. So T key of T in this case reflects T at name, which in this case would reflect John. Alright, so once we're done with this, we'll continue with looking at what do we need to do. Since we have a callback, we need to add the callback here. I would also say that maybe we do not need to have both descending and ascending stuff here. I would instead remove one of them. I would just have a sort function that I would have. So sort, and we could essentially also remove this thing at the top because I don't see any point using this strategy at all. So this is my way of saying that I would prefer not to work with strategies. I would rather try to work with generalized functions in this way. And we're going to explain to you shortly why and how that works. So let's continue. What do we need to do in order for us to continue with this? We want to find a way where we can sort it based on a property, and we want to be able to sort it based on nested properties without having to add too much logic. So in this case, A and B will be of type T. And what we want to do in this case is we want to do something, right? So we have a callback, which A value and B value will be received from. And the callback that we'll send in will be, for instance, if we have of type item, which is in our case, if you remember the John and ID case, we would be able to say item.name, and this would then, in this context, select the name, which would be John. So a value would be John in that case. All right, continuing with this, the B would be the same thing for the next object that we have. So if we continue with this, there's just a couple of things we want to do. I would say the return statement here is the else statement here is super redundant because we're returning. So just simplifying the code a bit, this is what we will do. And if we continue now, what can we do more? I think this would be good enough for now. We also want to be able to say sort ascending or descending, right? So that's an alternative that we wanted to have. So we would set order. Here we would have ascending or descending, and maybe we would have default value, which could be maybe ascending. All right, so we have three props that we can pass in with the default, which is going to be ascending. So let's create a object here for items. So we're going to say ID, one, name, John, and then we're going to continue to add a couple of more items, right? So let's add like 4 or 5 items. So one, we'll iterate through them and just keep on adding a couple of more items. So 1, 2, 3, Alex, and then we would go with Xavier for some strange reason, so that we significantly easily can see which order they should be without having to rethink too much. So now we have some items, right? So do we need the private sorting strategy anymore? No, we do not. Do we need the sort in descending? No, we do not. Do we need the ascending? No, in fact, we do not. So we could have a function now called sort by order, and if we want to be quite nice, we could also say the sort, we're going to export the enum sorting order. All right, so we'd have ascending and we'd have descending, right? Or if you want to make it a bit shorter, we could do ascending and descending in this way. All right, so we can also say that the sort order will be of this type, and we can also say that the default will be ascending. So now we have more type secure code that would handle this. Okay, so let me just comment out a bit. So we're going to sort by order. Here we do not need to have any anymore because we have the type. Let's imagine we would have the type interface person. All right, so the person would be ID and name in this case. So let's remove that from here. We could have the person, and we have the types here, person as well. We don't need to pass it in here anymore, and we do not need to return it either. So let's go ahead and say it's going to be of type void. And when we change the order, which in our case, we're going to say sorting order, or just order in this case, it's going to be of the type sorting order. So when we sort it, we want to call our sort function. So calling our sort function, the first prop we want to pass in really does not need to be a class anymore either. So all right, we're continuing to remove code. So export function instead. And this can also be of type T. So in order for us to use the T, we need to do it in this way. So to continue, let's go ahead and move it to the right place. I was a bit confused with how it was set up here because it's automatically adding new lines and so on, and remove one of the redundant things that we had here. All right, so sorry, it should be there, of course. So now that we have it in this way, we have a generalized function. We're going to get to the order real soon. So to continue with this, the way this would work is we would call our sort function. So we will import it from here. Let's remove some errors. So sort, and the first item would be the items. So this dot items, okay? Next thing we want to have, and let's not forget about it, we need to also receive the items here if you don't want to, if you want to be able to make hops and so on. So the first will be the items that we have. The second thing will be what in these items do we want to fetch. So in this case, we're saying the callback is going to be item dot name, so that when we come here and use the callback, it will in fact point out John and Alex in this case for A and B. All right, so the order has not been set yet, so let's go to the HTML and refactor this. So we have ascending, and this of course we need to have, since we want to have the best possible type security, we could either change it or we can make sure that we do not use enums. I usually use types. I think enums are good, but when you want to use them from the HTML, you need to define it in a specific way. So let's set just sorting order in this way, and now we can use the string, and we will still maintain the type security for the application. All right, so to continue, we have the ascending order. Now going back here, we can use the strings from the HTML without having this issue. So we could say ascending, descending, and we can continue with this. So if I would pass in something else, it should be, sorry, let's close this one and go to app component. So if I would pass in something else, I should receive the error, right? So it's only taking ascending, descending from this type. So now we have maintained the type security, but we have also been able to create something generalized for all objects and properties that we want to use, essentially. Okay, so to continue, now we're mainly focusing on objects and not singular values, because it's more of a valid use case that you want to sort objects that you have in front end. Alright, since we're not taking order into consideration at all right now, we need to also implement that. Let's do that quite shortly, okay? So first we want to see that this actually works. So we want to see that it actually sorts it. It's going to be in a ascending order. Let's try this out. So we're printing it in the HTML. Let's make sure that we have the screen side by side. Alright, so we'll just move this back, close this one, and put them side by side. So when we first come into the page, you can see that they're not sorted because we haven't added any default sort now. We could add that within the constructor or ng on init, but when we click on the button, you will see that now it's being sorted by name. So Alex, John, Xavier, so in an ascending order. So we want to be able to also sort in a descending order. So what we need to do is we want to have a variable here. So const is descending. So if it's descending, let's say the multiplier instead, we're going to use a multiplier. So if the order is ascending, we want to have 1, otherwise we want to have -1. So in this case, it will just flip these variables, right? So if it's descending order, this will be -1. If this is if it's descending order, and this one will be +1. So we're using the multiplier in order for us to flip these values. All right, so when I click on ascending, descending, we have the order now into consideration, so we should be able to just flip it. And as you can see, Alex, descending, Xavier. So they're flipping essentially. So this is one way of actually getting rid of this strategy pattern, creating something that's more useful, more effective, and can be generalized for all applications that you have. But there are very common and good use cases to use the strategy pattern, which in my consideration, I think that it's not for me. I would say strategy pattern is not for everyone. In my opinion, I think there's alternative ways to solve the issues. But if you would summarize the pros and cons, so the pros of using the strategy pattern would be that you encapsulate algorithms in a separate class, which makes it easier to maintain and modify without affecting other parts of the code. So for instance, now if we would have this sort function in there utilized by every single page that we have, it would be a mess to maintain and modify, because if you modify it one place, we might in fact cause issues in all of the other places that we have. So this is one good thing about strategy pattern, that it's more related to the actual use case where you use it, and also it increases the flexibility. So by using the strategy pattern, you can easily switch between different algorithms or strategies at runtime. As you saw, we could essentially call the instance of a certain clause, which could, for instance, we had the very basic clause here in our case. So that's why I think for that small case, creating a sort function would be valid. But imagine if you have 20, 25 functions or methods that needs to behave in a different way based on the selection. Then the strategy pattern would be optimal in this case, I would say. Also, it promotes a bit of code reuse, since each strategy is implemented as a separate class that can be reused in other parts of the application, so we could extend these clause. For instance, we had ascending descending now, but we could also build in a couple of different stuff within here. So obviously we're limited because of the sort logic, but if we would have greater objects that would behave in a certain way, we can change the behavior at runtime. All right. So separate concerns, it separates the code from implementing the algorithm from the code that uses the algorithm. So it promotes better code organization. So we do not need to handle everything in the actual component. We can handle it within the strategies, and we can just flip the logic from the components that we have. So as you know, there's a lot of cons as well. I would mention three of them. So as you saw, it requires additional clauses. So using the strategy pattern can lead to increased amount of classes that's being used, which can make the core mode more complex and harder to understand. And that's what I was trying to visualize, that we do not need to have the strategy pattern implemented for everything. In this case, you could create generalized functions to handle this kind of logic when it comes to sort in this case. But if I mentioned, if you would have more advanced strategies that you need to implement, then the strategy pattern would be something good to have. And as mentioned, it might increase complexity depending of the number of the strategies that you have and their complexity. The pattern can increase the complexity of the code, which means it might be very hard to maintain, to test, and so on. Also, the last thing I would like to mention is that there's a lot of overhead when it comes to the strategy pattern. It introduces the overhead due to that you need to create and manage multiple objects, which can impact the performance if not properly optimized. So here are the pros and cons. I think there is valid use case and not valid use cases where you can use the strategy pattern. The valid use cases would be when you have I would say, a bit of a larger clauses which needs to behave in a different way in runtime. Meanwhile, the smaller ones, so don't over-engineer it. I mean, for the sort ascending descending, that would be just madness to use a strategy pattern. I've seen many examples utilizing the sorting strategies for the strategy pattern. That's why I took it up here, and I wanted to explain that I think for the sorting purpose, it does not make sense at all. Alright guys, thank you for watching. All of the best. Bye.